Hello students. So as we are continuing the chapter acids, bases and salt, today we will discuss about bases. So today what we are going to learn, a little introduction about the bases, what are the different types and what are the uses of bases, and we will discuss a little about what neutral substances. So let's proceed. Now, like if we take some baking soda, all of us have got baking soda at our home. Now if we take some baking soda and test it, the baking soda, it appears to have a bitter taste, okay, and if we rub a solution of baking soda between our fingers, it feels what soapy to touch. That means it is slippery to touch. So these substances such as a baking soda, as I have already said, which are bitter in taste and feel soapy to touch, are known as bases. So as you can see in the slide, what is the definition of a base? Substances which can neutralize an acid to form a salt and water is called base. Okay, in our next class we will discuss about the neutralization, but for just now I want to say you what is neutralization reaction. When an acid reacts with a base to form a salt and water is known as neutralization reaction. Okay, now these bases, the chemical properties of bases are just the opposites of an acid. Okay, what are the properties of an acid? We have discussed in our previous class. Now when these bases are added to acids, they neutralize, or rather you can say cancel the effect of acids, right? So what is the taste of an acid? What is the taste of a base? Bases have bitter taste, okay, and in our last class we have discussed that acids, it has got what? Sour in taste, okay. Now next, the most important point is that bases turns red litmus into blue. In case of an acid, what we have learned? In case of an acid, we have learned that acid turns blue litmus into red. Here just the opposite thing happen. Here you can see in the diagram, if you take a red litmus paper and if you dip it into a solution of a base, immediately what you will find that it is turning into blue, okay. Now some different examples of bases are there, we will discuss later. Now what is an alkali? Base which is soluble in water is known as what? Is known as alkali, right? Now next, what are the types of base? Now how we can classify the base? We can classify the base into two categories. One is a strong base and another one is a weak base, okay. So weak bases are those bases which are closer to neutral substances, okay, and strong bases are those bases which are away from neutral substances. That means their pH are much higher, okay. Now what are strong bases? Examples of strong bases: sodium hydroxide and potassium hydroxide. Sodium and hydroxide and potassium hydroxide, both of this base, they are found in soap, okay. Next, weak bases. Weak bases, what are the examples? Here you see calcium hydroxide. Where it is found? It is found in lime water, okay. Magnesium hydroxide, it is found in milk of magnesia. What is milk of magnesia? It is a kind of antacid. When a people, they suffer from acidity due to excess secretion of hydrochloric acid in our stomach, then the people, they consume this antacid in order to neutralize, okay. Then ammonium hydroxide. Ammonium hydroxide is found in window cleaner, okay. Next, sodium carbonate, it is found in washing soda, and sodium hydrogen carbonate, it is nothing but the baking soda, which is used in case of baking. Now here you can see the different symbols and formulas of important elements and compounds. These are very, very important. Now as I have discussed, first sodium hydroxide and potassium hydroxide. As you can see over here, sodium hydroxide was, what is its formula? Sodium hydroxide, it is NaOH, okay. Na is the symbol of sodium and OH stands for hydroxide, okay. Similarly, potassium hydroxide, as you can find here, it is KOH, symbol of potassium is K, and then hydroxide OH, okay. Similarly, here you can see magnesium hydroxide, ammonium hydroxide, sodium carbonate, sodium hydrogen carbonate, plus in our previous class whatever acids we have discussed, those are also given over here, and this is very, very important. Now next is the neutral substances. Now before I discuss about neutral substances, one more thing I need to discuss, that is what are the main difference between an acid and a base. As I have said, in the sense of taste, acids, they have got sour in taste, Bitter, they have got what? Bases, they have got bitter in taste. Okay, acids are not soapy to touch, whereas bases, it feels soapy to touch. Then acids, it turns blue litmus to red, and bases, it turns what? It turns red litmus to blue, right? Now one more thing, as I have said you that like in our previous chapter we have read about that tooth decay. Now what happens, we know that some sugary food eaten by us, it is converted into acid by the bacteria present in our mouth, right? And this acid, it causes what? It causes tooth decay. Now the toothpaste that we use for brushing and cleaning our teeth, it is what? It is basic in nature. That means it contains what? Base. Now since toothpaste, it's basic, it neutralizes the acid in our mouth, and hence it prevents a tooth decay. Okay, so this is the main principle behind the use of toothpaste while brushing our teeth, right? Now next we will come to what? Next we will come to the neutral substances. Now what are neutral substances? Those substances which are neither acidic nor basic in nature are known as what? Neutral substances. Now being neither acidic nor basic, these neutral substances, it do not change the color of any indicator. Whatever indicator you use, you will not find any change of the color. Thus, if a solution of a substance in water does not change the color of either blue litmus or red litmus, then it will be a neutral substances. What are the examples? Pure water, or you can say distilled water. Okay, absolutely the pH is 7. Okay, neutral. Then glucose, okay, cane sugar and common salt. Right. Now one activity I want to discuss you, that how you can confirm the neutral nature of a substance by performing a litmus test. As you already know that litmus, it is a kind of indicator, okay, which is mostly used in the laboratories. Now let's discuss. For example, let us put one drop of distilled water on blue litmus paper and another drop of distilled water onto the red litmus paper. Now we will find that there is no change in the color of either blue litmus paper or the red litmus paper. So what does it show? It shows that the distilled water is neither acidic nor basic in nature. So what we can say, we can conclude that this distilled water, it is a neutral, right? Now same way we can show the neutral nature of glucose, cane sugar and common salt in a similar way by testing in their water solution or aqueous solution with blue litmus paper and red litmus paper turn by turn. So this is all about your neutral substances. In our next class we will discuss about the neutralization reaction, which is very important for this chapter, and we will discuss certain things about neutralization that happens in our daily life. Thank you everyone.